I'm going to go through your set of notes on sets and functions, and I'll go through all the different examples and just make sure that you've got them all copied down properly. So, higher maths, sets and functions. First page, we're not dead worried about this. It's giving you a wee bit of background information, but really the calculations later on are the more important ones, and I'll tell you as we're going through them. But basically, just to define what a set is, it's just a group of numbers. So it could be like 2, 4, 6, 8, 10 are all the even numbers, 1, 3, 5, 7, 9 are all the odd numbers. It's a group of numbers. Now, there's sets of numbers that are important in maths, and the first one is the natural numbers. That is something you can hold. It starts at 1, 2, 3, 4, 5. So I can hold 1 book, I can hold 2 books, I can hold 3 books. So they're called the natural numbers. Whole numbers are all the ones above, but we include 0 in that. Integers are all your negative numbers as well. So it's like your whole numbers with all your negative numbers onto it. Rational numbers have got this symbol Q, and you do not need to worry about this. If you have a ratio, it's another name for a fraction. So it's any numbers that can be expressed as a fraction. And real numbers, all real numbers, and irrational numbers. So irrational numbers are numbers that you cannot write down without rounding. So it might be the square root of 2. If you leave it like that, that's an exact value. It's not rounded. But if I worked it out, it'd be 1 point blah, 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 and it goes on and on. Pi is 3.14, and it goes on. So if I write it down as pi, we know exactly what it is. If I write it down as 3.14, I'd have to round it. Now, sets of numbers are put in these curly brackets, and again, that's not something that's dead important in higher maths. There's a wee curly brackets there, and that wee E shape just means it's a member of. So that means there 5 is a member of that set there. It just means there's a 5 in that group of numbers. If there's a line through it, it means it's not a member of that group. Okay, so for example, 5 is not a member of that set of numbers. It's not there. There's only 6, 7 and 8. There's no 5, so it's not a member. You can think of functions in what's called cloud diagrams. So a function is a set of rules which link an element in set A to one and only element in set B. That's maths speak, and it sounds hard. But basically, this is just what you did when you were in first year and you did machine chains. So you might have something like you saw a machine chain, and that machine chain might have multiplied a number by 2, and then it might even have added on 1. And you put numbers into that. So when you put numbers in there, if I put in there 3, I do 3 times 2 is 6, plus 1 is 7, out comes 7. I can put any number in there, any number at all. If I put x into that machine chain, it'd do x times 2 is 2x, 2x plus 1 comes out at the other end. I can't do the sum, so it's just 2x plus 1. So basically you're now doing your machine chains, but they're in a more grown-up way, they're more functions this time. So this here just means that you've got a domain. That just means all the x numbers, the input numbers. So that's the x numbers. That's the numbers you're putting into your machine chain. And this range means the answers that come out at the end. Now the answers usually, when you've got a formula, are the y values. Okay, so if you think of y is equal to 2x plus 1, then if x is 1, that gives us 2 times 1 is 2 plus 1 is 3. So the y number would be 3. So if we take this wee set, and I'm going to give it its set notation, so I'm going to say fx is equal to 2 times x. Now in the domain, I'm going to make up numbers 1, 2, 3, 4 and 5. I could put anything in there. The domain can be anything. Now, if that is the function there and it's 2x, then 1 would go to 2, because 2 times 1 is 2. 2 would go to 4. 2 2s are 4. 3 would go to 6. 4 would go to 8. And 5 would go to 10. So basically what we've got in here is we've got all the x numbers that are going in. So the x numbers are the domain. You've got to learn that x numbers are the domain. So x numbers are the domain. Okay. And y numbers, that's basically the answers. And they're given the value, or they're given the wee terminology of the range. It's called the range. Here's another wee one. So if I've got fx is equal to, we'll make it x squared. So if I put -1, I put 0, I put 1, I put 2, and I put 3. So -1 squared would go to 1. 0 squared is 0, and that goes to 0. And 1 squared is also 1, so 1 would go back up there. So you can see here in this set of numbers that I've got 1 and -1 going to the same value. So basically we've got to be careful with some of these machine chains, these functions, because we've got to, what they say, restrict the domain so that there isn't a number going to the same answer twice. So for this one, x squared, I might want to restrict the domain so that it's only 0 and all the numbers above it. And that means that I'm not getting this crossover where 1 squared is 1 and -1 squared is 1. And it would be the same for 2. 2 squared would be 4, -2 squared would also be 4. So you'd be getting an answer going to the same one twice. So basically, sometimes you've got to restrict the numbers you put in for x. Now this wee bit here, it says the set of functions works on, it's called the domain. Right, so domain is just x numbers. The values produced are called the range. That's basically the answers, and they're the y values. So for graphs and functions, we can think of the domain as the x numbers. There, it's all there. And we can think of the range as the y numbers. So that's what you've got to learn. So this means that any operation which produces more than one answer is not considered a function. For example, square root of 4 could be 2 or -2. There's a similar problem. Okay. So sometimes you've got to say, well, it's not given as a proper function, it wouldn't have an inverse, so therefore we've got to restrict the domain. And that means we've got to choose wisely the values of x we put into it, so that it doesn't happen. We don't get the same answer or the same value twice. Okay, so there was -1 and 1 went to the same value twice, and it'd be the same for that. If we had the square root of 4, then it would go to 2 -2. So sometimes we've got to restrict the domain. Now, sometimes functions you've got to state what the domain and the range is. So last year you learned about the graph y is equal to sine x. So we've got y is equal to sine x. You drew that graph, and when you draw that graph, right, just a wee reminder, there's x and there's y, and that graph looks something like that. Now this graph goes on and on, but we tend to only draw up to 360. So the domain here is 360. Now, that graph went up to 1 and it went down to -1. So when I want to know what the range is of this graph, the range is all the y numbers. So the range here, if we think about the y numbers, it goes between 1 and down to -1. So the y numbers goes between -1 and 1. So that is the range of those values, and they're allowed to also be equal to 1 and -1. So that's the range for the graph y is equal to sine x. Now the next one, I'm going to draw a wee sketch as well, because I think when you've got a sketch it's easier to see. So the graph of y is equal to x squared, and these things, you want to learn what these graphs look like. So this graph here, if I draw that down, y equal to x squared. X squared is a graph, it's a parabola, and it sits on the origin. That's what that graph looks like, and I should have put in x and I should put in y, and I'll go back and I'll do that here because I didn't put y in there. So if we want to find what's the range of values, so that's the origin, that's 0 on the y. It goes up to 1, 2, 3, 4, 5, 5, and it can keep going, doesn't stop. So basically the range of values for this one is that the y values are going to be greater than or equal to 0. So that could go on and on that graph, it doesn't need to stop. We can draw it as big as possible, and it just means that all the values of y are greater than or equal to 0. Now this next one, I'm going to draw this wee graph, and later on you'll know how to draw these graphs. For now, to get the range, we'll just talk about what the graph looks like, and we'll look at the y numbers. So basically, if I had the graph minus x squared, that's your parabola that's sitting on the origin and it's going upside down. It's like that. It's a maximum turning point to C. Now, if I've got 1 minus that x squared, then what happens is I've got a parabola, and it's going up to 1 and down like that. Now you don't need to worry about this right now, okay? So that there is, that wee value there is going to be up at 1. Now, that's your x numbers, that's your y numbers. Your range for this, so the highest point that reaches is y, and then all the y numbers all the way down there can be used. And again, I could keep going. So it could be 1, 0, -1, -2, -3, -4, and it keeps going. So the range of values for this wee graph is going to be y has got to be less than or equal to 1. So sometimes it's easier to see it from a graph. Okay, right, we'll go on and we'll do the next wee part. So the next part here is about these domain and ranges, and the domain is the number of the x's that we can use. Sometimes we can't use all the x numbers for the reason I said earlier. An x number might want to go to the same answer twice, so we can't have that. So we've got to restrict the domain. So this box here is really important. So the first thing it says is, when choosing the domain, okay, we must avoid 2 cases. The denominators cannot be equal to 0, because you cannot divide by 0. That means share into 0 bits. If you take something and share it into 0 bits, that's a magic trick. Everything disappears, there's nothing there. So that cannot be done. The other thing is, you cannot find the square root of a negative number. Put it in your calculator, you'll get syntax error or whatever else. You cannot find the square root of a negative numbers. So those 2 things there define what x numbers you can use. Now you will have seen this in your National 5, but you probably didn't even take any note of it, and it wasn't important there, but it was important for the questions, so it's always written at the side. So for this one, for example, fx is 1 over x plus 5. Now it says here x cannot be equal to -5. Why is that? I'm going to go down here and I'm going to look at that down here. We've got fx is equal to 1 over x plus 5. There's the denominator. The denominator cannot be equal to 0. You cannot divide by 0. So x plus 5 cannot be equal to 0. And we solve that wee equation just the same way as if it was an equal sign. Take 5 off both sides. So x cannot be equal to -5. And that's what's written there. So x cannot be equal to -5. You don't need to worry about all that. That just means x is a member of all the real numbers. X is not equal to -5. That's the important bit. Now, this one here, for gx, we've got gx, and gx is equal to the square root of x minus 3. So we cannot take the square root of a negative number. So instead of saying it's not to be negative, we've got to say then that that thing under that bracket has got to be greater than or equal to 0. So x minus 3 has got to be greater than or equal to 0. And that means that no negative numbers are included. You can take the square root of 0. Square root of 0 is 0, but you cannot take negative numbers, and that's how you define that. So that just means it's not negative. Okay, so it's not negative. It's got to be greater than or equal to 0. Right, so we solve that again. So I don't want that -3 to be there, so x has got to be greater than or equal to, add 3 onto both sides, plus 3. And that's how you get your domain, or the highest possible domain. So in that function, you could use 3, 4, 5, 6, 7, 8, 9, 10, and that is okay. And you can see it written there. X has got to be greater than or equal to 3, and I've just shown you why. There's a fancy way of writing it. Don't worry about that. You don't need it. X is greater than or equal to 3. Now we've got a couple of other examples here to do. So it says for each function, state a suitable domain. So when you're doing this, you're looking for 2 things. You're looking for dividing anything in a denominator, or you're looking for a square root. There's no denominator here, so it's a square root 1. So the square root is 3x minus 2. That cannot be negative, so that means that 3x minus 2 has got to be greater than or equal to 0, because all numbers greater than or equal to 0 are positive. Okay, They're not negative, so no negative numbers involved there. So we solve that wee equation. So we'll add 2 onto both sides. So 3x has got to be greater than or equal to 2. But I don't want 3 times x, so I'm going to divide by 3. So x has got to be greater than or equal to 2/3, 2 over 3. And that gives a suitable domain. So that's a domain where I will never be taking the square root of a negative number. Now the next one, p theta. Theta tends to be used if we're talking about angles. So we don't need to worry about that just now either. We're dividing by something, so there's something on the denominator. So the denominator is 5 minus theta. I know the denominator cannot be equal to 0, so I write that in. 5 minus theta cannot be equal to 0. Now I've got that wee equation to solve. So I could take 5 away from both sides, so minus theta cannot be equal to negative 5. That's negative 1 times theta, so I'm going to divide by negative 1. So theta cannot be equal to 5. And that's the largest and most suitable domain for that function. Now, this one here, this has got a lot going on in it, because I've got a square root and I've got a denominator. So I know that bottom bit cannot be equal to 0, because I can't divide by 0. And I also know that the square root cannot be negative. So I'm going to take it in 2 steps to do this one. Okay, and then we'll look at the answers when we get to the end. So I know that the square root of y minus 1 cannot be equal to 0. Can't divide by 0. Now I'm going to square both sides to get rid of that square root. So when I square that side, I get y minus 1. But when I square 0, 0 times 0 is still 0. So y minus 1 cannot be equal to 0. I don't want to have that take away 1, so I'll add 1 onto both sides. So y cannot be equal to 0 plus 1 is 1. Now the other thing that I've got to think about is, because we've got a square root in there, square root can't be negative. So it's not just 0, it cannot be negative. So if that can't be negative, y minus 1 has got to be greater than or equal to 0. Can't be negative. That's another way of describing it's not negative. Okay, and I'll put that in there. It's not negative. It's greater than or equal to 0. It's not negative. So solve that wee one. Add 1 onto both sides. So y has got to be greater than or equal to 1. But we can't have that equal to 1 because of this rule. So therefore, when I combine both of them together, I can say that y has got to be greater than 1. And that covers that, but it also covers that. So that one was saying y has got to be greater than or equal to 1, but that told me I couldn't have 1. I couldn't use 1 because I can't divide by 0. So therefore, I combine those two together and I get y has got to be greater than 1. Now, this is where your exam questions come in. This is the important bit. So it says in the linear function, and linear function just means it's the equation of a straight line, y equals mx plus c. That's all linear function means. It says here, to get y by doing 2x, you multiply by 3, then you subtract 5. So it's like your machine rules. Multiply by 3, take away 5. Because you're doing two things, we're saying that this is a composite function. It's composed, it's made up of two different things. So what we want to do is we want to combine those two things together and get a wee formula for doing that. So in this first one down here, we've got fx is 5x plus 1 and gx is 3x squared plus 2x. Now, we can think about what does function f do to the thing in the bracket. So x is in the bracket. So it does 5 times the thing in the bracket and it adds on 1. So 5 times the thing in the bracket plus 1. What does this function gx do? So gx does 3 times the thing in the bracket all squared plus 2 times the thing in the bracket. And you can put them into a wee box and it lets you see what those functions are doing. And it means when you've got more complicated things, you're just sticking a formula into those boxes. So fx is 5 lots of x, but it depends what's in there. So it's 5 lots of whatever is in that bracket. And then you add on 1. For function gx, it's First of all, the thing in the bracket squared, and you times it by 3. So it's 3 times whatever is in the bracket squared, and then you add on 2 times whatever is in the bracket. So the first thing we want to do in this first one is we want to find f of g minus 1. So I'm going to do g of minus 1. So write it in here, g of minus 1. So what does this function g do to the thing in the bracket? So it's minus 1 now. So it does 3 times minus 1 all squared, add on 2 times minus 1. And when I work that out, minus 1 squared is 1, 3 ones are 3, 2 times minus 1 is minus 2, so that is equal to 1. So because it's a number that's used in this one, then that just means I'm doing f, and I know that g minus 1 is 1, so that's what I write in. Write the answer in. Now, what does function f do to the thing in the bracket? It does 5 times the thing in the bracket plus 1, 5 times the thing in the bracket plus 1. So when I'm undoing, or I'm trying to work out function f, I do 5 times the thing in the bracket plus 1. 5 ones are 5 plus 1 is 6. And that's the final answer to that one. Now, for you to understand things here, they're giving you numbers. It's supposed to make it a bit easier. Sometimes it makes it harder. Very rarely will you be given a number like that. It tends to be find f of gx, f of fx, g of fx. So they keep it as a formula rather as numbers. Right, so we'll do part B. So the first thing you do, you write down f, and if it's gx in this bracket, you write in the formula for gx. So gx was 3x squared plus 2x's. So that's the first thing you do. You substitute in the formula whatever is in there. So gx, they tell you what it is, you put it into that bracket. Then the next thing you do is you've got to say, right, okay, this function f is doing something to the thing in the bracket. What was function f doing to the thing in the bracket? Function f was doing 5 times the thing in the bracket plus 1. So it's 5 times the thing in the bracket plus 1. And if you write it down like that, then it might be easier to see what you're doing. So the thing in the bracket was 3x squared plus 2x. And then we do that wee algebraic manipulation to work this out. So 5 times 3x squared is 15x squared. 5 times 2x is 10x. And then we've got a plus 1 tagged at the end. And that gives us our function f of gx. Now the next two you've got to do are down here. This one is f of fx. It makes no difference that they're the same. So you write down function f, and in the bracket we've got fx. So we put in what fx is, which is 5x plus 1. So we write in there 5x plus 1. Now, what does function f do to the thing in the bracket? So function f multiplies it by 5 and it adds on 1. Function does 5 times whatever's in the bracket plus 1. So it's 5 times whatever is in the bracket plus 1. It's 5x plus 1 that's in the bracket. So we tidy that up. 5 times 5x is 25x's. 5 times 1 is 5, but we've got another wee one tagged at the end. So that then gives me 25x's plus 6. And that's f of fx. Okay. Okay, last one here is g of fx. So again, same rules apply all the way through. Write down function g. In the bracket, we put in the formula for fx. So fx is 5x plus 1. So 5x plus 1 goes in there. Now we look to see what does function g do to the thing that's in its bracket. So function g does 3 times the thing in the bracket squared plus 2 times the thing in the bracket. So 3 times the thing in the bracket plus 2 times the thing in the bracket. So 3 times the thing in the bracket squared plus 2 times the thing in the bracket. And sometimes it's easier just to write it like that. And then go back and put in what you've got there in the bracket. So it's 5x plus 1. And that's 5x plus 1. Okay. Now, we've got to square this first, and then we multiply it by 3. So the 3 stays there, and I'm going to square this the quick way. Okay, so to square something the quick way, you square the first term. So 5x times 5x is 25x squared. You multiply the two of them together and then double it. So 1 times 5x is 5x, double it, so it gives you plus 10x. And then you square the last number, so 1 times 1 is 1. And that's how you square a bracket. It's important that you start to learn to do that because it cuts down all the work that you need to do. Now 2 times 5x plus 1, I can do that easily. That's 10x plus 1. I've still got to multiply out this bracket here. So we've got 3 times 25x squared, so that's 75x squared. And then I've got 3 times 10x is plus 30x. And then I've got 3 times 1 is plus 3. But don't forget, we've got a 10x plus 1 stuck on there at the end. So now we need to just tidy that last bit up. There's only one set of x squared, so that set of x squared is 75x squared. I'll add the x's together, so I've got 30 of them and 10 of them, so it's plus 40x's. And then we'll add the numbers together, so we've got a 3, and that wee one in there's 2 times 1 is 2. Hope we spotted that wee mistake. So I've got 3 plus 2 gives us 5. And that's your function f of gx, or g of fx I should say. Right, that's the sort of questions that you're asked to do in your exam. So it's really important that you practice them. Next part of your notes, it says usually f of gx and g of fx are not the same. They're not meant to be the same, but there can be a time where they do work out to be the same, but that's just a coincidence, it's not a rule. So we've got one example here. So we've got example 4, fx is 2x plus 1, gx is x squared plus 6. So what does fx do to the thing in the bracket? It multiplies it by 2 and it adds on 1. What does function g do to the thing in the bracket? It does the thing in the bracket squared and it adds on 6. So that's basically what these two functions do, and we're going to use that to work out whatever they ask us. So first part here, I've got f of gx, so we write down f. We substitute gx into that formula, which is x squared plus 6. Then we look to see, well, what does function f do to the thing in the bracket? Function f does 2 times the thing in the bracket plus 1. So it's 2 times the thing in the bracket plus 1. Now the thing in the bracket here is x squared plus 6. And then all I have to do is tidy that up. So 2 times x squared is 2x squared. 2 times 6 is 12. And we've got a wee 1 stuck on at the end of there. And that gives us 2x squared plus 13. So the next way, I've got f. We've done f of gx, now we have to do g of fx. So write down g, and in the bracket we'll put fx. So fx was 2x plus 1. So straightforward substitution. Whatever's in there substitutes into that bracket. Now we want to know what g does to the thing in the bracket. So g takes the thing in the bracket, it squares it, and it adds on 6. So it takes the thing in the bracket, it squares it, and it adds on 6. What is the thing in the bracket? The thing in the bracket here is 2x plus 1. So we've got 2x plus 1 all squared, add on 6. We're going to learn to square brackets the quick way. So square the 2x, square the first. So 2x times 2x is 4x squared. Multiply the two terms together. So 1 times 2x is 2x, but we want to double that, and that gives us plus 4x's. And now square the last term. So plus 1 all squared, 1 times 1 is 1. And don't forget there'll be plus 6 in there. So we'll now tidy that up. So we've got 4x squared plus 4x plus 7. And that's g of fx. That's it all done. Now sometimes it can give you a wee problem. Here's a wee problem here. Solve the equation f of gx is equal to g of fx. Right, so we've already worked out f of gx. There it's there. So it's telling me that 2x squared plus 13, that's that bit, and that's got to be equal to f of gx is 2x squared plus 13. G of fx is that one there, and we worked it out to be 4x squared plus 4x plus 7. I'm going to gather all the x squareds together, all the x's together, and all the numbers together. Now, because there's a bigger number of x squared on there, and you'll learn all these wee tricks as you go on, I'm going to read that round the other way. So 4x squared plus 4x plus 7 is equal to 2x squared plus 13. So two things I want to do. I don't want that minus 2x squared to be on that side because we've got a quadratic here. Quadratics must be equal to 0. So I'm going to take 2x squared away from both sides. Now, I've also got plus 13 there. Can't have that, so I've got to take 13 away from both sides. I'll take 13 away from there, and I'll just line it up under the numbers. I take 13 away from the number. So when I do that, I end up with 4x squared take away 2x squared gives me 2x squared. We haven't done anything to the x's, so it stays as plus 4x's. And then I've got 7 take away 13, and 7 take away 13 is minus 6, and that's equal to 0. Now we've got to solve this, so we're solving this quadratic equation. When we're solving this quadratic equation, we've got a 2, we've got a 4, and we've got a 6. So we're going to take out a common factor of 2, which is x squared plus 2x's minus 3, and that's still equal to 0. I can now just divide both sides by 2, and it leaves me with a much simpler quadratic equation to factorise. And I'm going to quickly factorise that one, and you'll learn to do this as the year progresses as well. So I know that x squared has got to just be x times x, and I know that 3 is a prime number, so it can only come from 3 times 1. I know I want a plus 2, but we've got a minus 3, so one of the factors is minus and one is positive. One is positive, one is negative, I should say. So if I want plus 2x, I must have plus 3 minus 1. Okay, if you still need to factorise a long way, then that's okay, but as the year goes on, you will learn to do it quicker. So x minus 1 is equal to 0, or x plus 3 is equal to 0. So that means x is equal to, add 1 onto both sides, x is equal to 1, and x is equal to, take 3 away from both sides, minus 3. So you can see already that your National 5 is overlapping here. You've got wee bits to do. Whenever you've done the higher part of it, you might have a wee bit to do that goes back to National 5. Okay, example 5 in your notes. We've got fx is equal to 3 divided by x plus 1. Now here it's saying x is not allowed to be minus 1. They're stating the domain. You don't need to worry about it, but that's why that's there, because the denominator cannot be equal to 0, so x plus 1 cannot be equal to 0. Take 1 away from both sides. X cannot be equal to negative 1. So that's there, and it's been there when you were doing National 5, etc. It just, you didn't really know what it was all about. Right, we've got to find an expression for f of fx as a fraction in its simplest form. This is going to be a harder one because we've got the x's down at the bottom, but we do exactly the same as what we've always done. So if we want f of fx, we'll leave the f outside the bracket and we substitute fx into the bracket, and fx is 3 over x plus 1. Now, what does the function f do to the thing in the bracket? So I'm going to go over here. So function f takes this thing in the bracket and it does 3 divided by the thing in the bracket plus 1. Okay, so the thing in the bracket is there. That's there. So we now have to do the same here. So it does 3 divided by the thing in the bracket plus 1. Now, we substitute what's in the bracket. And the bracket is 3 over x plus 1. Now, that looks horrible. That's a horrible mess. And the thing that makes it a horrible mess is this fraction down here at the bottom. So we use a wee trick to get rid of it. If I don't like something, I can multiply top and bottom by that and it will all disappear. So I'm going to multiply the top by x plus 1, and I'm going to multiply the bottom by x plus 1. So when I do that, in the numerator, the top of this, I get 3 times x plus 1. And in the denominator, I multiply this thing first by x plus 1. X plus 1 cancels. That was the whole point of it. I'm just left with 3. Much, much easier. And then I've got 1 times the thing in the bracket there is x plus 1. And I can tidy that up. So I get 3 times x plus 1 divided by, that's going to be 3 plus x plus 1. And when I fix all that out, I've got 3 times x plus 1 all divided by x plus 4. You can multiply that out if you like at the top. So that's the harder ones. Now, that looks harder, that looks terrible. If you learn just to multiply by that horrible fraction, top and bottom, then it means everything disappeared from that fraction. So that disappeared, and I was left with 3 times what I multiplied by. The x plus 1 disappears there, so I've just left with 3, and 1 times x plus 1, and I just tidy that up, and it makes it much, much easier to work with. So the last wee section we've got to do here is inverse functions. Inverse just means round the other way. So here's your wee definition. It says if a function links every number in the domain to only one number in the range, the function is called one-to-one correspondence. And what that looks like when it's one-to-one correspondence is every single thing in the domain, the x numbers all go to 1 in the y, in the domain. So that's domain, that's range. And one-to-one correspondence means 1 goes to one thing, 1 goes to one thing, 1 goes to one thing, and they're all linked. Everything is linked. Now, when you've got that, you can do an inverse function because everything over here has got a root to go back. So the inverse function, that would go back to there, that would go back to there, and that would go back to there. So there's a root back, so it's got an inverse. Now, down here, there's a wee example. It says f(x) is 2x. The inverse would be the function, which cancels it out. So the opposite. So the opposite of multiplying by 2 is to divide by 2. In other words, half something. Now, you're asked to do 2 things. You're asked to find a formula for the inverse function, or you're asked to draw the inverse function when you're given a graph. And it's dead easy, because what happens here is, I'm going to go back up to that. That was x, and that was y. So when you've got an inverse function, you've got it the other way around. The y's go back to x's. So x and y are swapping over whenever you are doing an inverse function. So you do that exactly. You swap the x's and the y's round. So f(x) we know is equal to y. So y is equal to 2x plus 5. We change the subject to the formula to x. That's why you did it in National 5. I'm going to write this round the other way. So 2x plus 5 is equal to y. So 2x is equal to, take 5 away from both sides, so it's y minus 5. I don't want 2 times x, so I want to divide by 2. So I've got y minus 5 all divided by 2. Now that gives me my answer for the inverse function. There, it's there. That's the answer. But you can see that there's a y in there, and they want f minus 1, f inverse of x. So all we do is we write f inverse x, and we change the y back to an x, so it's equal to x minus 5 over 2. That could also be written as a half bracket x minus 5, and that's the inverse function. So it's not a difficult process to do, it's just a straightforward change in subject of a formula. Right, likewise for this one here, f(x) is equal to half bracket x minus 9. So we know that f(x) is y, so y is equal to a half x minus 9. We'll write it round the other way because x is on the right hand side. So a half x minus 9 is equal to y. That means 1 times that divided by 2. I don't like to divide by 2, so I'll multiply both sides by 2. So that means 1 lot of x minus 9 is equal to 2y. All I have to do then is undo this, take away 9, so I add 9 to both sides. So x is equal to 2y plus 9. That's my answer. I'm going to highlight it. There, it's there, and that's the answer there. But we don't ever write our functions in terms of y, it's always in terms of x. So we finish off by saying f inverse x is equal to 2x plus 9. And that gives me the formula for the inverse function. Next 2 examples in your notes is we want to find the inverse function of both of these, so it's part C and part D. So we start off with y is equal to 9 minus x over 2. Now normally I would write that round the other way, but it's minus x over 2, so I'm going to add x over 2 to both sides. So x over 2 I'm adding to that side, there's still a y there, and on this side I'm left with 9. Don't want the y to be there, So I take y away from both sides. So that's 9 minus y. I don't want divided by 2, so I times by 2. So x is equal to 2, and because there's more than one thing there, to put it in a bracket, 9 minus y. So that is the answer sitting there. All I have to now do is to write down the function. So that means that f inverse of x, I don't want the y's in the answer, I want x's in it, is 2 times 9 minus x. Next one, part D. So for part D, we've got y is equal to 3x cubed minus 4. I'll read it round the other way, so 3x cubed minus 4 is equal to y. Don't want the minus 4, so I'll add 4 onto both sides, so that gives us y plus 4. Don't want 3 times that x cubed, so I'm going to divide by 3, so it's going to be y plus 4 all divided by 3. And how do you undo x cubed? You take the cube root. So x is the cubed root. Make sure it's a great big root sign and make sure everything's tucked underneath it. So it's y plus 4 divided by 3. That's now the answer. I'll highlight the answer. So there is the answer sitting there. And all I have to do now is finish it off. You must do this last wee step and write down what you were asked. So you were asked to write down the formula for the inverse. So f inverse in terms of x is equal to the cubed root of x plus 4 all over 3. This last example, there's your notes there. It says if f of gx is equal to x, then fx and gx are inverse functions. That is a wee question, usually worth a wee mark, but it comes up in your paper. So if you do f of gx or g of fx and the answer turns out to be x, it means that you've started at x, you've gone somewhere else, and you come back to x. So they're inverse functions. So as soon as you see an answer of it equal to x, whatever it is, then you know that f and g are both inverse functions of each other. So this one here, it says fx is equal to 2x plus 5 and gx is equal to x minus 5 over 2. And we've got to show that gx is equal to the inverse of x. So how do we do that? We do f of gx, or the other way around, it doesn't matter, is equal to, and we want a final answer of x, so we've got f, we'll leave that in there, we put in gx as x minus 5 over 2. What does function f do to the thing in the bracket? Function f takes the thing in the bracket, it multiplies it by 2, and it adds on 5. So to finish this off, we've got 2 times x minus 5 all over 2, and then it adds on 5. So when I do that, I need to multiply this thing out. So I've got 2 and 2, they cancel each other out. So I'm just left with x minus 5 plus 5, and x minus 5 plus 5 gives me a value of x. There's the magic answer. So f of gx is equal to x. So as soon as you get that answer, which is just an x, that's an indication that those two functions are inverses of one another. And that's us. We've showed that gx is the inverse of f. It can be the other way around. F is inverse of gx. And that's your all your stuff done in inverse functions. The only thing we've now got to do is the graphs. I might as well do it and finish it just now. Okay, to get the graph of an inverse function, what you do is, it's down here, it says the dotted lines in each diagram are the lines y equals x. In each case, the graph is an inverse function, and it can be obtained from the graph of the original function by reflecting it in the line y is equal to x. So we're pretending that that's a mirror. So if that's a mirror, I want to draw the line that basically treats that as your mirror. So it's the same in the opposite side. So in this case, it's going to do something like that. Okay, and I'm going to adjust this just so that they cross at the same bit. So what I've got here is every point should be the same distance across the mirror. So that point there, I've not drawn it particularly well, that should be 5. Those both cross on the mirror there. And you can see that if that was a dividing line, it's not accurate, it's not really exactly, because this bit's a wee bit bigger, but you can see that that line splits that diagram down the middle, and that's what you're doing. Now, if you're doing this in class, you can rotate your paper round so that that line there is sitting straight up and down and it's easier to see. Okay, now the next one, we've got to draw the graph of x over 2, so that's a half x take away 9. So a half x take away 9, it's going to be the equation of a straight line. Usually you're given the first graph, you're not usually asked to draw it yourself. Okay, but because they're straight lines, it's just been given as a formula. So that there is the graph y is equal to a half x, x over 2 minus 9. So that graph there cuts down at minus 9. So when x is nothing, half of nothing is still nothing, minus 9, the y coordinate is 9. And then you could work out these other ones if you want. Right, so I've got to now reflect that graph in that dotted line. So I'm pretending that dotted line is a mirror. And I'm going to draw the other part of that. So the other part of that will do something like that. I'll keep going. So that is your inverse graph. Now, if that was minus 9, then that one there has got to be up at 9. Okay, the mirror should cut both of them in half, and that's your graph y is equal to f inverse of x. Okay, and that one there, that was your graph y is equal to 2x plus 5, and that one there was inverse y is equal to f inverse of x. Okay. In fact, it was the other way around. That was your original graph, and that was the other one. Okay, so I'll change that. Okay, so your original graph, the first one I did was that one. So that's y is equal to 2x plus 5, and that's the y is equal to f inverse. Okay, it doesn't matter, as long as you've done them and they look the same. Right, there's another one of them we have to do. So the next one we've got is this one here. And I'm going to draw this one out first. Okay, example 9, it says gx is x cubed plus 6. Sketch the graph y is equal to gx. Now, the graph of x cubed, that's the graph that looks like a twisted parabola. So it does that. Now, we've added on 6, so it comes up to 6. And again, you'll learn how to draw these at some point in your next topic or whatever. So that's the graph, y is equal to x cubed plus 6. We now want to show that g inverse is that. So we do the same as what we did before. Y is equal to x cubed plus 6. Read it round the other way. X cubed plus 6 is equal to y. So x cubed is equal to y minus 6. I don't want x cubed. Take the cubed root. So the cubed root of that whole thing there. I've now got my answer. There's the answer sitting there. But remember, we've got to change it back to x's. So g inverse of x is equal to the cubed root of x minus 6. And that's what they asked us to do, so that's right. Now down here it says, hence sketch the graph of that. So what we're going to do is, we are going to basically draw that there on the other side of this. So when I do that, I know that that point there is 6, goes straight across the mirror, that point there must be 6. That one's almost at the mirror, so I'm going to do a wee dot there. So when I'm drawing this, it does something like that, and it goes to 6, and then it turns and it comes away. So you can see that I've drawn basically the other half of that diagram. So that there is a graph of y is equal to g inverse of x. It takes practice drawing them. They're not always dead easy to draw, but if you turn your paper round, then it should make it look a bit easier to draw. Okay, your notes finish off with a past paper question. It's important to go on and find your past paper questions and try and do them all. So it says functions f and g are defined in a set of real numbers by fx is x squared plus 3, gx is x plus 4. So function f, what does it do to the thing in the bracket? It squares it and it adds on 3. What does function g do to the thing in the bracket? It writes it down and it adds on 4. So now we want to find an expression for both of these things. So write down f, put the formula for gx in there, so that's x plus 4. Then we've got to see what function f does to the thing in the bracket, so it's squared it, and it adds on 3, so I've got x plus 4 all squared, and it's plus 3. Now we want to square this the quick way, so we square the first as x times x is x squared. We multiply the two of them together and double it, so 4 times x is 4x, double it, and it gives us 8x. Square the last, 4 squared is 16, and then I've also got a b plus 3 stuck in there. And all I have to do is tidy that up. So that gives me x squared plus 8x's plus 19. Now we have to do it the other way around. We want to find g of fx, so we write down g, we substitute the formula for fx in the bracket, and fx is x squared plus 3. What does function g do to the thing in the bracket? It writes it down and adds on 4. So it writes it down and it adds on 4. So that becomes x squared plus 7. And that's your two composite functions done. Now, this last wee bit is another wee question that's kind of a test on what you did in National 5. So it's not a new topic, you've done this before. It says show that f of gx plus g of fx is equal to 0, has no real roots. So if something's got no real roots, b squared minus 4ac has got to be less than 0. Okay, so that's from Nat 5. So it's bringing in wee bits of your Nat 5 here. So we're going to do what they've asked us to do. So we're going to write down f of gx. So that's x squared plus 8x's plus 19. And then they've asked me to add on g of fx. I'm going to add on, and there's g of fx. I'm going to add on x squared plus 7. And they've said to make it equal to 0. So that's equal to 0. So now we're going to tidy that up. So we've got 2x squareds, and there's only one x term, so it's 8x. And then we've got 19 plus another 7, and 19 plus 7 is 26. And that's equal to 0. So what you can do is you can take out a common factor if you want from that. So if I take out a common factor from that, I've got 2 times x squared plus 4x, and that would be plus 13. Divide both sides by 0, and that makes that x squared plus 4x plus 13 is equal to 0. So we want to show that this has got no real roots. So I want to work out the discriminant, and it should be negative. So we've got a is equal to 1, b is equal to 4, and c is equal to 13. So b squared minus 4ac is going to be equal to 4 squared minus 4 times 1 times 13. So that would give me 4 squared is 16. 4 times 1 times 13 is minus 52. I'm going to check that. So that would be minus 52. And when I do 16 take away 52 is not 54. I'm writing down 54 and I said 52. So it's 16 take away 52. Then that gives me, and it's obviously going to be negative, it gives me minus 36. So state your conclusion, since b squared minus 4ac is less than 0, there are no real roots. Now, I've just gone over all of your chapter, so that would maybe be a week's work. So do a wee bit, stop it, look at the time along the video, do some exercises that you've been asked to do in class, and then start it again and go back over it and make sure that you understand it and replay it if you need to.